Okay. Now we are moving into lecture number 30. Lecture 30, EMF equation. EMF equation of alternator. Now, this is the derivation actually. This is one of the derivation for 10 mark question. So please listen carefully. Derivation. Consider a single conductor placed in a slot. Okay, placed in a slot. The average value of EMF induced in a conductor equal to T phi by dt. T phi by dt, where phi is the flux per pole in Weber. WB stands for Weber. Now we have to write some of the parameters. Name. P is the number of poles. Ns. What is Ns? Anyone?
Synchronous speed.
Synchronous speed in RPM, revolution per minute. F is the frequency of induced EMF. I think someone unmuted. Please mute your mic. Please mute your mic. Induced EMF in hertz. Frequency of induced EMF means it is a rotor frequency. And one more term we have to use Z, where Z will be the capital Z. Okay. Total number of conductors. And one more notation, Z phase, where Z phase is the conductor per phase, because we are giving 3-phase line, so for every phase there will be one conductor connected in series. Okay, therefore Z phase is equal to Z divided by 3 has how many number of phases in 3-phase line? 3 phases. Okay, number of phases equal to 3. That is RYB. RYB. Okay. Now by using this notations, we have to find the for one revolution. Okay, conductor. A conductor. One revolution of the conductor notation E suffix AVG. Okay, average per conductor. E average equal to flux cut in 1, because 1 hour the flux will be cut, then only EMF will be induced. Okay, and you have to calculate for every time. So time taken for one revolution. Time taken for one revolution. Therefore, the total flux cut in one revolution equal to flux phi into P, where P is number of volts, phi is flux. And time taken for one revolution equal to 60 minutes, right? 60 divided by ns, unit seconds. Therefore, substitute these two parameters in our equation. Therefore, E average per conductor equal to, so what is the flux cut in one revolution? Flux into P. Okay, substitute phi into P divided by time taken for one revolution is 60 by ns. So therefore, this ns goes to numerator. Phi P ns by 60. Phi P ns by 60. But we know that F equal to P ns by 60. That is frequency of induced EMF. So frequency of induced EMF, it is P ns by 120 degree. So hence here you have to substitute this P ns by 60. I can write because this 120 I can write it as 2 into 60. equal to F. Therefore, PNS by 60 equal to, this 2 goes to right hand side, 2 into F. 2 into F. Now, this 2 into F value, okay, you have to substitute because this equation you mark it as 1. Okay, substitute PNS by 60 equal to 2F in equation 1. Therefore, E average per conductor equal to 2F into T. Okay, 2F into, sorry, 2F into 5, because here this PNS by 60 I am writing as 2F, so 2F into 5. Okay, so this is the EMF average per conductor. Now this average per conductor we can represent in terms of the number of turns. Okay, so in terms of number of turns, the EMF per phase is equal to T phase. T is the number of turns per phase. T phase is the number of turns per phase. T phase into average EMF per turn, which is equal to T phase into how much average per conductor? 2F into 5. Okay, 2F into 5. Okay, this is the average EMF per conductor. But in terms of per turn is 2 into this 2F 5. Therefore, E phase is equal to T phase into 4F 5. 4F 5. Okay, so now we have to represent, because here we are this machine will be operated by a 3-phase line. It will be alternating quantity. There will be a form factor which is available. Form factor means 1.11 times of sinusoidal EMF. Therefore, this form factor notation Kf equal to RMS root mean square by average. This is the formula. Okay, RMS by average, which is equal to 1.11. Okay, this formula you already studied in your first year, basic electrical engineering. Now by using this, we have to find out the RMS. So RMS is equal to the RMS value of E phase is equal to Kf into average value. So how much Kf? It is 1.11. Okay, this substitute here. 1.11 into how much average? 4f 5 t phase. 4fi t phase. Therefore, E phase is equal to 1.11 into 4. 4.44 F 5 T phase. The unit for this EMF equation is volts. Okay, this is the EMF equation of induced EMF per phase of alternator. Okay, this is the EMF equation. This is one 10-mark question. EMF equation of alternator. Any doubts?